Hi, my name is Thanujan. I'm a final year QT student studying a civil and structural engineering degree. I like challenging myself and to learn new things, hence why I chose a career in engineering. I'm very passionate about structures with a key interest in bridge engineering. The building sector contributes to approximately 40% of the total global greenhouse gas emissions. A reduction in this industry would make a significant contribution. Taking that into consideration, my final year project idea is to compare the embodied energy of an internal flow plate system of an office building designed by concrete, timber, and composite materials. The predominant objective to carry out a study in this topic is towards aiding sustainable development by quantifying the embodied energy of three different flow plate systems. The aim of this project is to identify the flow plate system which consumes the lowest embodied energy and carbon. The key research questions to be addressed in this topic include: what are the embodied energy values of reinforced concrete, composite, and timber flow plate? How do we optimize the design of the flow plate systems to get less embodied energy values? How will the initial design and optimized design be used in a real-world application? The benefits to the environment in terms of sustainability due to this research. The rise of concentration of carbon dioxide in the atmosphere is one of the main reasons for global warming and climate changes. Therefore, it is critical to reduce carbon emissions in the future through the use of energy optimization and renewable energy production. The total life cycle energy of a building accounts for the embodied energy and operational energy. The embodied energy is consumed during the extraction of raw materials, manufacturing, construction, and demolition of buildings. The use of energy-efficient equipment and advanced material have reduced the operational energy significantly in buildings. Therefore, it is important to research ways of reducing embodied energy. By doing this project, it will be possible to recommend a better material to be used in office floor plates, as a material with less embodied energy reduces the carbon emissions produced. This research will involve designing three different floor plate systems using three different materials, and then calculating the embodied energy values, and a comparison will be carried out. The first semester of the research will focus on designing three different flow plate systems and comparing the embodied energy. The second semester will focus on optimizing the design to be more energy efficient. The methodology for the first semester will take place in 5 levels. The first one would be analyzing the loads acting on the flow plate system, including the sulfate. The second one would be the preliminary member sizing and structural considerations to be considered. The third one would be designing the flow plate system according to the relevant Australian standards. And the fourth one would be calculating the embodied energy and carbon values based on the design. And the fifth one would be comparing the results. The results obtained from this research can be used for structural designers and architects to choose the flow plate system which emits the less carbon dioxide to the environment. The optimized design could be followed to achieve a more sustainable design. This would be a good practice for designers as it reduces the greenhouse gas emissions and drives the communities we live in to a cleaner and greener environment. The supervisor will provide the relevant structural schemes and design specifications needed for the design of the flow plate systems with concrete, steel, and timber. Funding will not be required as most of the data will be freely accessible. SAI Global would be used to access the Australian standards. A suitable database will be identified to find relevant coefficients of embodied energy and embodied carbon, which will then use to be calculate the embodied energies of the flow plate systems. Thank you so much for taking the time to watch my video. Also, by the way, I like playing soccer. Please make sure to like, subscribe, and comment below if you want a shout out for my next video. Bye for now.